Now let's try to understand what is beta and gamma function, how they are defined. See, beta function is defined as, we write it as beta Lm equals to 0 to 1 x L minus 1 1 minus x m minus 1 dx. This is how we define beta function, where L and M are positive, So we can write where L and M are positive numbers. They are positive numbers. So we write it like this. Gamma function is defined as gamma n equals to 0 to infinity x n minus 1 e to the power x e to the power minus x dx. This is how we define gamma function. See, these integrals are very useful. These integrals are very useful in calculation, in some integration that is involved in calculation of volume surfaces. These integrations are very important at times. See, we have to understand some properties of these integrals. We have to understand some properties, like say, if I write gamma n is 0 to infinity x n minus 1 e to the power minus x dx. So if I integrate it by parts, it will become minus of x n minus 1 minus ex from 0 to infinity, then plus, we can write it as n minus 2 x n minus 2 e to the power minus x dx. So this integral will be 0. This will be 0. Sorry, this will be n minus 1. Sorry, this is n minus 1. Minus 1. Make one thing. This is n minus 1. Grab it. So this is n minus 1. Okay, differentiate it, it will become n minus 1. So this becomes, this is 0, this is n minus 1, 0 to infinity e to the power minus x, and this x, n minus 2 can be written as n minus 1 minus 1 dx. So what is this? This becomes equal to gamma n minus 1. This is n minus 1 gamma n minus 1. So we have the property gamma n is written as n minus 1 gamma n minus 1, which can also be written as n minus 2, and gamma n minus 1 can be written as n minus 2, and so on. So if your, say, n is a positive integer, if n is positive integer, and I can write gamma n as n minus 1, n minus 2, n minus 3, 2, 3, 2, 1, and gamma 1. So what is gamma 1? You put here 1. This is x0, that is 1 e to the power minus 6 dx. This will become how much? Gamma 1 will be e to the power minus x dx. So this is minus of e to the power minus x from 0 to infinity. This will become 1 itself. So gamma 1 is 1. So this becomes n minus 1 factorial. So if n is a positive integer, gamma n becomes n minus 1 factorial. Gamma n is n minus 1 factorial. Right. So let's see other properties. See other properties. I won't prove it here, but you must remember, because that is very useful when you go for volume and surface calculation. Other properties are like beta Lm equals to beta Ml. This is one property. You can prove it. Now I can write beta function in terms of gamma function as beta Lm equals to Other properties are beta Lm equals to beta Ml. So beta, I can express beta function in terms of gamma function as beta L m equals to gamma L, gamma m, and gamma L plus m. I am not proving it. The proof won't be asked in your exam, so I am not proving it. You just remember it. Beta L m equals to gamma L, gamma m, gamma L plus m. You have some other properties of gamma function also, like gamma 1 by 2 is root pi, gamma 1 by 2 is root pi, gamma 1 is 1, gamma 0 is infinity, gamma 0 is infinity. Now let's try to understand some of the transformation of gamma function. You have a topic, transformation of gamma function. Let's try to understand some of the transformation of gamma function. See, suppose what the transformation is, let's put into this 0 to infinity x n minus 1 e to the power minus x dx. Let's try to put x equals to log 1 upon y. Let's try to put x equal to log 1 upon y. So this is minus log y. So your dx will be minus 1 by y dy. dx will be minus 1 by y dy. And e to the power minus x is e to the power minus, it says minus log 1 by y, or this can be written as e to the power log y. So this is y itself. Now let me rub all this. So what this will become equal to? This will become equal to, see, this is integral. See, when x is 0, when x is 0, your y will be, I can write y is 1, and when x is infinity, log y is infinity, so y will be 0. So log y is minus infinity, so log 0 is minus infinity. So I will put it as x n minus 1. X n minus 1 is log 1 by y n minus 1 e to the power minus x is y, and dy is minus 1 by y dy. So this will be minus of 1 to 0 log 1 upon y dy n minus 1. So I can shuffle the limits, take the minus sign inside, so it becomes 0 to 1 log 1 by y n minus 1 dy. So this is, so I can convert the beta function, the gamma function can be written like this also. This is one of the transformation, one of the famous transformation. Now let's look at the other transformation. Let's look at the other transformation over here, right? So now let's put x
equals to cy. So your dx will be c dy. So this is gamma n. Gamma n is 0 to infinity e to the power minus x. So I can write it as 0 infinity e to the power minus cy, and this will be cy n minus 1 c dy. So this will become equal to cn 0 to infinity e to the power minus cy y n minus 1 dy. Alright, so so we can put 0 to infinity e to the power minus cy y n minus 1 equals to dy.
equals to gamma n upon Cn. Alright, this will be useful at various places. This will be very useful. Now let's see other transformation. Like suppose I put xn equals to y, or x will be y1 to the power n, and dx will be 1 by n dy. Right, so your gamma n, this is given as 0 to infinity e to the power minus x n minus 1 dx. So this can be written as 0 to infinity e to the power, I can write it as e to the power y1 by n, e to the power y1 by n, and xn minus 1 will be y n minus 1 upon n. This will be 1 by n y 1 by n minus 1 into dy, 1 by n minus 1 into dy. So this can be written as 1 by n 0 to infinity e to the power minus y 1 by n, and this will become 1 dy. So I can write 0 to infinity dy equals to n gamma n, that is n plus 1 gamma n plus 1. This is n plus 1 gamma n plus 1. So these are some of the transformations which are very useful. These are some of the transformations which are very useful. Now we will see some transformation of beta function. See, beta function is defined as beta Lm equals to 0 to 1 x L minus 1 1 minus x m minus 1 dx. Now if you let us put x equals to 1 upon 1 plus y. So your dx will be minus 1 upon y d square into dy. So, and 1 minus x is going to be 1 minus 1 upon y plus 1 upon y. So your beta Lm is defined as, see, when x is 0, when x is 0, what is the y? Y is infinity. Y is infinity. And when x is 1, y is 0. So this is x L minus 1. So 1 plus 1 upon y, L minus 1, and y m minus 1, 1 plus y, this will be m minus 1 and minus 1 plus y whole square dy. So this will become equal to minus of infinity to 0 y m minus 1 and 1 plus y L plus m, or we can write it as 0 to infinity y m minus 1 1 plus y dy. Now since your beta Lm, beta ml, so we can also write this beta function as, I can shuffle this L and M, and I'll get 0 to infinity y n minus 1, sorry, L minus 1, sorry, y L minus 1 1 plus y L plus m dy. So this is one transformation. This is very important. This is one transformation. Let's look at the other transformation. Let's put x equal to sine squared theta and see what is the transformation. Let's put x equal to sine squared theta. Say, let's put x equals to sine squared theta. Your beta function is beta Lm equals to 0 to 1 x L minus 1 1 minus x m minus 1 dx. So if I put x equal to sine square theta, what is your dx? 2 sine theta cos theta d theta. So 1 minus x is going to be cos square theta. So your beta lm is will be, see, your for x equal to 0 your theta is 0, for x equal to 1 your theta is pi by 2. So this becomes sine 2 into L minus 1 theta, and 1 minus x is cos square theta. So this is cos 2 m minus 1 theta. This will be 2 sine theta cos theta d theta. Alright. So this becomes equal to twice of 0 to pi by 2, and this is multiplied. So this is sine of 2l minus 1 theta d theta. So your we arrive at a very important formula which is used in the future, the next chapter. This is sine 2l minus 1 theta cos 2m minus 1 theta d theta is coming. This is 2m minus 1, right? This is twice of m minus 1. Okay. So this is equal to 1 upon 2 beta lm, or in terms of gamma function I can write L into m twice of L plus m. Alright. So this is how we can transform it. We can do one more thing. Let 2L minus 1 is P and 2M minus 1 is Q. In that case, the integral 0 to pi by 2 sine P theta cos Q theta can be written as, in that case L becomes P plus 1 by 2 Q plus 1 by 2 and twice of P plus Q plus, this is d theta also, this is d theta. So this is P plus Q plus 2 by 2. This is very, very important. This will be very, very important. Alright, this will be very, very important. Please remember this. This is very useful. Like if you have to solve, say, 0 to pi by 2, say sine Q theta and say cos 4 theta d theta. That's can be simply solved by this, using this. So this is what? 3 plus 1 by 2. So it is 2. 4 plus 1 by 2. So this is 5 by 2. And twice of, say, 3 plus 4, 7 plus 2, 9. So this becomes 9 by 2. This will become how much? This will be equal to gamma 2 is 1, and I can write gamma 5 by 2 and 9 by gamma 9 by 2 can be written as 7 by 2 gamma 7 by 2, and gamma 7 by 2 can be written as 5 by 2 gamma 5 by 2. I can write this as gamma 9 by 2 can be written as 7 by 2 gamma 7 by 2, and gamma 7 by 2 can be written as 5 by 2 gamma 5 by 2, and I can cancel this. So this becomes equal to 2 upon 35. This is 2 upon 35. Alright. This is how we can do it. Alright. This is how we can do it. We can solve it very easily.